Hello all, welcome to Hashi Talks. We've had a great day so far already, so looking forward to all the talks in the next couple of days. It's going to be great. We're all learning a lot of things together. So the next 30 minutes, we're going to be talking about Spring Boot, Spring Cloud, and how we can actually use them for Vault and Consul integration for your microservices. Primarily, I'm going to be focusing on secret management, and we all know why that is so important in your microservices. We have all kinds of needs in our microservices with sensitive, dynamic secrets. They're all time-bound, so we have to pay close attention to lifecycle, when to renew, when to revoke, and so forth. Access control is super important. We also need a lot of flexibility in terms of how we want to use secrets, in terms of APIs and and the encryption needs, and also different needs for different kinds of applications, right? Configuration management is equally important in your applications. This is usually non-sensitive in nature, but it is really important to actually keep your microservices in sync and make sure that you can actually apply changes on the fly and be super sure that it's been applied consistently across your cloud infrastructure and your microservices. So that's super important as well. We also want the capability to watch for changes as you deploy your code, or you want to apply just configuration changes when they change. Maybe an example of that would be changing your logging levels for some troubleshooting something in your microservice on the fly. So that is something that we want absolutely in your applications. Service discovery is another area that I'm going to be talking a little bit about, and how we could use them in your microservices and the role Spring Cloud plays in your application. Also talk a little bit about service-to-service communication, handshakes, as well as load balancing, and I'll also show some reference architectures for how we could actually apply that to your service mesh. Before we move forward, I'm Kris Iyer. I work as a principal architect at Houghton Mifflin Harcourt. Houghton Mifflin Harcourt is a tech leader in the K-12 space. We deal with students and teachers and all of the school districts across the globe, and we are mostly focused on core, curriculum, supplemental, and intervention solutions. So, as part of our day jobs, we work a lot with HashiCorp products. We also work closely with AWS as well as Kubernetes. So, looking forward to actually spending the next 30 minutes with you all. Before we move forward to Spring Cloud, I want to, for folks who are relatively new for Spring Boot, I want to just give you some background for what that brings to the table. It's really a nice framework on top of Spring for a Java stack. It allows you to build APIs and microservices real fast and real easy. That's one of the biggest benefits I've been seeing in microservices development, and what Spring Boot brings to the table. Auto configuration reduces a lot of complexity. Doesn't allow you, doesn't basically avoids writing a lot of boilerplate code. It's easy to administer and manage, and it's got great support for administration, metrics. You name it, it's already got it. Tracing, auditing, applies the best practices such as IOC, security. Spring Security is a great framework. MVC, data access patterns using JPA, transaction management. It also is great for test frameworks. So it's really easy to build something real lightweight, real fast. Maybe you're part of an agile team. Spring Boot fits in nice and neatly into that framework, where you could just focus on application business functionality and spin up your services real lightweight, performant, and scalable, and deploy to the cloud, and just focus on aspects that you want to deliver as part of your sprints. And you can, being a pluggable module, you can actually bring in additional features on top and keep iterating. So that's one of the beauties of the microservice. Talking a little bit about Spring Cloud, what this brings to the table is really best practices that you would want to apply to your microservices as they mature. They're in the cloud. You want to actually think about distributed configuration. You want to think about service registration and discovery. How do you actually communicate between services? And so that you can actually avoid some hard coding. Maybe you want to respond to dynamic changes in your service dependencies. How do you route to them? How do you make secured handshakes between these services and load balance? Circuit breaking, for example, rate limiting, circuit breaking, you name it. I think Spring Cloud has a little module that supports it. So that is going to be focusing mostly on Spring Cloud modules that actually support distributed configuration and service registration, discovery, as well as secret management today. So here's a little reference architecture for a microservice that actually is deployed on a Kubernetes stack that is integrated with Consul and Vault for configuration and secret management. So you can see Spring Cloud has a bunch of modules that have been imported in here in this architecture, where it uses a Cloud Consul config module to integrate with Consul. It's got a Vault module that integrates with secret management. It's also got a Spring Cloud AWS module integrated, which can actually talk to Vault and the AWS backend. So here's a little example where the services actually are watching for changes in Consul KV. They're also integrating with Vault. And it's also, you can also see an arrow going from Vault to Consul, where Vault is actually integrated and also protecting your access to Consul for a service. So you would obtain a Consul token from Vault before your application can actually query in a Consul KB. And likewise, there is a plethora of backends that are supported by Vault already, as you know. Consul for the Consul security aspect, and KV, real simple, static credentials that you would want to store in Vault. AWS backends are great for IAM, STS, or any other kinds of authentication that you want to do perform against your cloud providers, such as AWS. Database backends are very popular. In your microservice as well, you want to secure your database credentials, which is a very common use case that we run across. And on top of that, you could also secure service-to-service communication in this pattern with Consul, such as Consul intentions, right? You can actually define rules, configurable rules that you can actually manage through Terraform, for example, and apply them so that you can actually say that service A is allowed to talk to service B or vice versa, right? Now you could really, in the microservices world, that's what we usually struggle with, where you have either too many microservices, and access control is always a challenge, like who gets to call what, and what the roles might be. So that's one integration pattern where you're using Spring Cloud Consul and Spring Cloud Vault with the various secret backends. Here's an alternate architecture, which you'll notice that on the left things remain the same. You're still talking from Spring Cloud into Spring Cloud Consul. On the bottom, you see a little difference, where you have a little volume that is mounted onto your application. This could be injected. There's a pattern which you can actually commonly use, which is a sidecar pattern in Kubernetes, where you could actually run a Vault agent as a sidecar. What that does really is when your applications come up, it injects a little init container, which actually seeds the volume with a secret that you want. It could be any backend that you integrate with that makes it available to the application on startup. And then the Vault agent sidecar is responsible for rotating and maintaining the lease and so forth. So it'll maintain the secrets on file or on the mount, basically for your application. So that is also another pattern that is commonly used along with Kubernetes. So we talked a little bit about backends here. So the secret backends that are supported by Spring Cloud Vault at the moment are KV, which is the Vault KV. It supports the Vault Consul backend. It also supports Vault AWS backend for secrets and RabbitMQ. There's also a lot of databases that are supported already. One of the beauties of this integration was prior to Vault, Vault versions actually supported a direct connection to your database, just MySQL or Postgres, and Spring Cloud Vault has a module for your database, a relational database, either MySQL or Postgres, but those have been deprecated since Vault 7.1. Since then, we've had a generic database backend, which can be used to connect to any database of your choice that Vault already supports to rotate secrets and so forth. So this is great for integration. In addition to the databases, it also supports Elasticsearch that is also available right now with Spring Cloud 3.0 and higher. It also supports a variety of authentication frameworks. Token authentication is very popular. You would use that for local development, for example. You have your cloud provider-based authentication schemes like EC2 and IAM for AWS, or Google Cloud Compute Engine for GCP. Kubernetes authentication if you're in a Kubernetes deployment environment, and likewise in a bunch of others. It's very easy to configure. On the right, I show a little example of how you would authenticate using a Kubernetes role and service account role. and just configure that. It's as simple as dropping a few lines of configurations in your YAML file in your Spring Cloud configuration, and you're up and running with that. So here's an example of how you could get started on Spring Cloud and start integrating your applications with Vault. So you start with defining your host and port, your scheme. You want to make sure you're using HTTPS if possible at all times. You could also use a URI if you choose to. It makes it a little easier. It gets a higher precedence as far as Spring Cloud is concerned. It would ignore the host, port, and scheme if you configure a URI. You could configure timeouts as necessary. One of the key pointers in here is your configuration order. So that is something that you want to pay close attention to as well. You might have competing priorities that you want to load in your application. So you want to have to make sure that what you're reading from Vault gets a higher priority as well, and make it available to the application at Bootstrap. So you have the default orders are not specified, but you could give it one, for example. In addition to that, you could also basically use a discovery client, such as Spring Cloud Console, and also discover Vault. So you don't have to actually even code in the URI in here. You could actually configure Spring Cloud to be saying, and I want to discover Vault, and you can actually just specify a Boolean value in the configuration, and it would do that for you when you're working with a discovery client. So that's something that's available. In addition to that, Vault enterprise customers can actually use a namespace, so that's supported as well. In addition to that, you can configure SSL for your connection and fail fast if you choose to in your development environments, for example. The Vault lifecycle configuration is super important as well. You want to make sure that you get this absolutely right. You want to make sure that your tokens are not set for a long TTL, and that's the whole point of making it more secure, so that you can have a framework such as Spring Cloud Vault that can manage secrets and make it available to your application at all times, and make it as secure as possible. So you want to make sure your minimum renewal is set to something reasonable. You don't want to renew it too often. At the same time, you want to make sure your expiry thresholds in your application is set to something reasonable as well. And Spring Cloud Vault would do the magic for you accordingly. The lease endpoints are also important to configure. Prior versions greater than 8.8 actually use a leases endpoint. So you want to configure that for the newer API, and legacy versions are set to legacy. So it supports both at the moment. But I think moving forward, I think you want to be using the leases as much as possible. Auto wiring is something that's the core of Spring Boot and Spring Cloud, right? So you'll have a lot of use cases where you have auto wired dependencies. So how would you make sure that the leases that you're actually maintaining through Spring Cloud and Vault primarily, how are they actually going to be injected into your application? It's very common to have an application, let's say, you want to connect to S3, and you would have an S3 client which actually uses S3 credentials. I'm going to code STS for a moment. So you would have to have an access key, a temporary access key, a temporary secret, and a session token to be able to make a connection to Spring Cloud and to S3. So in that case, I would have a bean. I would have an S3 client injected into it, which is going to have the credentials that it's going to need. It's going to have a credential bean that you would want to actually seed your S3 client with. So I would, in that case, I would want to actually make sure that when the lease expires, I would want to make sure the S3 client has got access to the latest set of access keys and secrets in the session token. So that's an example where you could actually define an application context-aware bean, such as a configuration, and tap into the lease container. So the Spring Cloud lease container is actually listening into all of the events. As the lease rotates, it's going to basically generate a new lease. It's going to say, it's going to have an event published called the secret lease created event. There's also a bunch of other events you could, if you're interested in, but this is one of them that you would want to tap into and register a lease container, a lease listener, and do some custom stuff, right? So an example of that would be, in the example I quoted earlier, would be to rebind your application auto-wide beans. For example, if it's a configuration properties, you would want to use a configuration properties rebinder that would automatically re-inject any auto-wide dependencies as you rebind. Another alternative would be to use a refresh scope in your application, which is a cool way of telling the Spring Cloud environment that this is a bean that needs to be reloaded upon changes to configuration, right? So you want to say, you want to mark those beans as refresh scope, and you could actually perform a refresh on a specific bean of choice, or you could just reload. Spring Cloud Console Watches is another example where it detects a change in a configuration. It would attempt a refresh automatically to all refresh scope beans that are attached to the container. So Spring Boot config data is another pattern that was introduced in Spring Boot 2.4. This is the newest way, which is the recommended way of importing data sources, which is it could be a Vault data source or a console data source. You have multiple ways of fetching those properties and initializing them in the application. The older way, the legacy way of doing things, is the bootstrap method, where you would actually have a bootstrap YAML and configure everything. The newer method is to actually use spring config.import, and you have a bunch of options in there. So you could make some things optional. Let's say you probably don't care about this option because you might have an override somewhere else. So you could mark some services as optional if you like to. And then you could also specify an order. For example, the last one is what is loaded first. So if you say spring config.import console, Vault, Vault is a property source that is loaded first, followed by console. It might be important in the future where you would want to actually have contributions from property sources being used by the other. And there's a little lone issue about this, which we'll talk about a little later in the presentation. And I'll introduce you to some of the issues in that space as well. But this is a great option for folks who are using Vault and console integration. But we have a little issue with ACL. So if you're using console with ACL, there is a little issue in communicating with Vault and console with the config data import API. Spring Cloud Vault console is the method that you would use to actually obtain a token from console for console for your application. So if you have Vault and console both in the environment and you want to authenticate to console, you would specify a Spring Cloud console token in order for your application to talk to console KV, for example. So you would want to configure a particular role, also configurable through Terraform, for example, and specify a backend of console. And you would actually configure a Spring Cloud console token or a property of your choice. But ideally, Spring Cloud console token is a default that is seeded by the property source, and you would use that in your application. Same thing for KV, supports a lot of different secret endpoints. So the default is secret/application, which is the application name in your Spring Boot application /profile. It could be dev and cert, your certification or staging environment or prod. So you'll have a profile. So Spring Cloud is going to scan all of those places and the paths in the secret for you and automatically do the property source injection. So one of the key highlights in here is basically your profile separator. You want to make sure that your profile is separated with the known tokens, depending on how your secret is specified. So if you use a path separator, you want to make sure that the profile separator is set to a path separator. So Spring Cloud AWS is another module that you can inject in your application, and you can actually integrate. It used to be only supporting IAM user until Spring Cloud 3.2, 3.2 and higher supports STS. So we have introduced assumed role functionality as well as federation user support for Spring Cloud. So if you use assumed role, you would also want to make sure that your IAM role is specified and the role ARN is specified as well. So you might have multiple ARNs. If you have a single ARN, great. That's an optional setting. If you have multiple, you want to make sure you want to specify a role ARN. And it also integrates with Spring Cloud AWS, which will seed cloud.aws.credentials for access key and secret, as well as a session token property. So that's a great option if you want to acquire temporary tokens in addition to IAM user. The generic database, we talked about that a little bit. It's great and easy to configure. Something to note real over here is that the properties that are seeded are spring.datasource.username and password. These are standard properties that you use in Spring Cloud and Spring data sources that you want to actually make sure that there is no real conflict in the application. So, but real straightforward to configure. Enabling is easy. You could configure a role that can integrate with your relational databases or NoSQL databases for that matter, and be able to inject that into your application. Spring Cloud Console KV, we talked about that a little bit as well. Something I want to highlight in here is that it has great support for different formats of properties that you want to inject. You can have a YAML file, or you can have a property file. You could actually use, you can use the files option to actually synchronize a whole bunch of folders into console KV if you choose to. That's a very common use case as well, where you would have application configuration within your application, as well as you could have applications that are externalized to your application, which could be synced up in console KV as a file, and that will be also imported as a property source into your application. So that's something to look forward to in terms of integration, ease of integration as well. So here's an example of how you could actually apply Vault and Consul on a CI pipeline, and there could be multiple use cases for it, or you could have a CI tool of your choice. In this example, I'm talking about Conquer CI, which actually uses a couple of resources. There is a console KV resource, which allows you to integrate with console. There's also a Vault resource that allows you to talk to Vault to obtain tokens. So a use case would be that you want to actually obtain a token from a deploy key, for example, a secure deploy key for GitHub that could be stored in Vault as a static credential. It could be fetched using a Vault resource. Or, like I said, you want to synchronize a whole bunch of configuration for your application. You could use a pipeline-based setup where you could have console KV resource actually synchronizing that for you and make it available to your application. Both configurable through Terraform as well. So we're talking a little bit about test containers in here, which is super important in your pipelines. So test containers are a great way to actually test your code. I also not only use that for testing our code, but also testing upgrades to Vault, testing upgrades to console. It's a neat way to actually make sure your Spring Cloud dependencies are basically tested against a version that you're supporting in your production environments. So that is pretty easy to integrate and configure for your applications. Spring Boot tests, like integration tests, integrate really well with test containers, and you can actually have a container of Vault for Postgres or for console. It's super easy to integrate. Here's an example for console. This is a relatively new project, which is not available until 2 months ago. This is a new open source that we published, and this is something that allows you to configure ACLs and also build a console cluster if you choose to with this library. Same idea, testing console in your pipelines. You could also have use cases where you want to connect two different containers. So you want to have intra-container connectivity. For Vault and Consul is a perfect example where you want to configure a console backend and you want to have Vault talking to the console container. So, and test containers actually make it super easy where you have a little DNS that is exposed over a port, and you can have a host.test containers or internal that you can actually use to communicate between test containers. So it makes it a lot easier for a variety of use cases that you want to configure. Talking a little bit about Spring Cloud Discovery. It's super easy to configure that in your application. All you do is add a little annotation to the top of your code, say enable Discovery Client, and that would actually basically auto-inject all of the code that is required into your application and basically be allowing you to talk to console and discover services that may be already registered with console, and also use load balancing if you choose to. So you could do some client-side load balancing and come up with a registry of services that you want to talk to, and let console manage that, and the discovery client look up the service endpoints, and you could use a standard web client or web flux or even REST template for that matter to actually talk between services and load balance them. So that's super easy as well. A little bit more complex situation would be a service mesh. It makes it easy for service-to-service communication, but obviously from a security standpoint, it's going to be a lot better. You could have MTLS between them. This picture actually shows console in the mix with Console Connect and Envoy as a proxy for your Kubernetes deployment, which is actually forming a service mesh. And you can see MTLS between your pods. So service A talking to service B and being load balanced to different pods in service B, for example. So that's made available through Console Connect, and it's easy to inject an annotation into deployment with which says connect service upstreams, and you can actually say service A gets injected with upstreams with service B. So all deployment configuration, nothing in code, just makes it possible to actually inject a whole bunch of upstreams and just make a lookup and have a secure handshake between your services. It'll honor intentions as well, being Console Connect and talking to console. All your intentions are honored here as well. So Vault and Console health contributors might be important to view to your application, because if you're using static credentials and you only use them at Bootstrap, it might not be super important to actually always, take it down your part, or basically throw your health check off if Vault or Consul is down. But usually, that is something that you want to turn on for best practices, and that is available as well. So Actuator is the management endpoint for Spring Boot, and you have a /health, and you have a management health check group for Consul and Vault, and there's a health contributor for each of them. There is a little issue with Consul health contributors, which I'll talk about in a minute as well. So a couple issues, and I would want to highlight in here. One particularly is about config data management. So if you're using the config data API, you would want to make sure that that is in the setup where you have Vault and Consul, for example, and you would want to have Vault bootstrap first, acquire a Consul token for you, and then make your bootstrap with Consul KV. So you want to have Consul token available at the right time in your application. So there is a problem where the contributors right now in Spring Cloud, where Vault would be, even if Vault was the first one to resolve, would actually grab all of the tokens, but it is not made available to the contributors downstream. So there is an open issue for that, and there is a workaround. I'll also talk about that. And we talked about the health indicator. It's a minor issue that in the Spring Cloud Consul project, where the health contributor is not made available for Consul, and there is a workaround for that as well. So here's a little workaround where you would basically, for the first issue, where you would want to have the Consul token be available to the Consul KV bootstrap phase, is to actually register a Spring factory with the Vault for Consul bootstrap configuration file, which is actually listening into the application context aware interface, and it is actually getting hold of a configurable environment and seeding the properties using a Vault operation. So it's actually grabbing a token for you as part of the bootstrap phase and injecting that and making it available right in time for you. So that's not great, but is a workaround that works. And for the health contributor, it's a real minor issue where you would want to actually look at all health contributors in your current application context as well as in the parent application context. That's a neat fix. Again, not great, but works nicely. A lot of references in here. Want to close out the talk with providing you an example for Vault and Consul integration. It's got a Docker Compose template. If you want to play around with it, feel free to. It allows you to start up Vault and Consul along with test containers for Vault, Consul, and AWS integration. It's got some APIs that you can play around with. You can try out a local AWS local stack implementation with S3 if you like. There's also the Spring Cloud team-based examples that is published by the Spring Cloud team. So you can actually play around with a lot of different token authentication and also discovery client, for example. A couple blogs that I referenced in here that talks about STS integration specifically, which is relatively new, as well as configuration management patterns. That is really it. Thank you all for listening into my talk. And I really want to close out by making a shout out for the Spring Cloud team, the Spring Boot team, for the constant support with HashiCorp modules, and obviously the HashiCorp team for Vault and Consul and all of the SDKs, and a little shout out for our Docker team as well and test containers to make it super easy for building microservices on the cloud and testing them. So thank you all. I hope this was useful to you, and looking forward to all the great talks next couple of days. Thank you.